Alright, we're going to graph a secant function. So we're going to follow the steps from a previous video that look like this in your notes. So we're going to be working with the inverse function first to follow those 6 steps. So in the red, I'm going to rewrite it as the inverse function, so -3 cosine of, and then change that x over 2 to 1/2 x. So now let's identify the amplitude first. The amplitude is the absolute value of the a, which is 3. So you really won't have an amplitude, but that tells you that you have a vertical stretch by 3. There is a horizontal reflection because the a is negative. So normally in a cosine function for the parent, it would start at the top and work its way down. But for this problem, it's going to start at the bottom. It's going to reflect about the y-axis and then work its way down. So we will not have that first example. We will have the second one as a graph. All right, continuing on, we want to identify the period. So we're looking at the b value, which is 1/2. So 2 pi over 1/2. So we have to keep the 2 pi. We have to change that to multiplication, and then we have to flip the 1 over 2 to 2 over 1, and then multiply across. So 1 revolution is stretched out to 4 pi. There is not a plus d, so we do not have a vertical shift. Then we look at our 1/2 x. To find the left endpoint, we're going to set that 1/2 x equal to 0. And then the right endpoint, we're going to set that 1/2 x equal to 2 pi. And now we solve them both for x. So we're going to multiply by the reciprocal of 1/2, which is 2 over 1, to both sides. So the left endpoint is at 0. Do the same thing for the second equation. We're going to multiply both sides by its reciprocal of 1/2, which is 2 over 1, and then multiply across. So your left endpoint will be at 4 pi. So we're going to first start graphing the inverse function with 2 full revolutions. So we're going to graph this red function right here. So just writing this down, the period was 4 pi. We had a reflection, and there was a vertical stretch by 3. So here is 0. I'm going to make this 4 pi. I'm going to do 4 equal increments. So halfway would be 2 pi. Halfway again would be pi. Halfway again would be 3 pi. I'm going to stretch my vertical axes up 3 and down 3. Now we're ready to start to graph it. So your left endpoint was at 0, and your right endpoint was at 4 pi. So with a reflection about the y-axis, we have to start at the bottom instead of at the top of that 3. So we go to the center, the top, the center again, and then the bottom. So here is 1 revolution for our cosine function. I'm going to extend it another revolution to the left. And continue that pattern. So there is 2 revolutions. Now I'm going to change colors. I'm going to graph the inverse function of the cosine. So that is the secant. So you want to find where the graph is undefined. So those x-intercepts. So at 3 pi, at pi, at negative pi, at negative 3 pi. And we're going to create those vertical asymptotes. Label those asymptotes. X equals 3 pi, x equals pi, x equals negative pi, x equals negative 3 pi. Now we're ready to reciprocate between those asymptotes. So on the hills, we're going to reciprocate them. So we're creating those, what I call parabolas, but they're really not parabolas. And what we have in the purple is the actual secant function.